You. Aha. So now let us start with question number 7, probability. So question number 7, it reads as follows. It says to us 7.1, an entire sample space is made up of two complementary events, which is event S and event T, where probability of S prime is equals to 0.33. So now here we are given, they say we have the entire sample space. It is made up of two complementary events. This word is very important, complementary events. So when they say events are complementary, what does that mean? That means when you add probabilities of those events, when you add them together, they're supposed to give you one. Probability of A plus probability of B is equals to 1. Why? Because event A and event B, they are both complementary, hence why their probabilities add up to 1. So now here, this prime, it simply means not. So meaning here we are given probability of not S. Okay, this is the same as probability of not S. This is another notation that we can use to write probability of not S. We use S prime over there. Okay, so if it is not S, that means what is it? It's anything else except S. So 7.1.1, it says to us, complete the statement. What is the probability of A plus the probability of T? What is the probability of, sorry, not A, what is the probability of S plus probability of T? Based on the very same information provided to us, they said S and T are complementary. So that means probability of S plus probability of T is equals to how much? Is equals to 1. Why? Because they are complementary. Even S and T, they are both complementary. So that's why it's equals to 1. Easy as that. 7.1.2, write down the value of probability of T. They want us to write down the value of probability of T. So what is the probability of T? Remember, these two events, they are complementary, right? And remember, we are also provided with probability of not S. So for a fact that we have only two events, which is S and T, and then we have probability of not S. So that means if it is not S, what is it then? That means it's probability of T. Okay, so probability of T is the same as probability of not S. So what is the probability of not S? Probability of not S is equal to 0.33. So that means probability of T is the same as 0.33. This is easy as ABC. Grade 1's work. Now 7.2, it says to us, a survey was conducted among 180 residents of a small town to establish how many people contracted tuberculosis and or human immunodeficiency virus, which is HIV, during the last 5 years. The results were as follows. X people were diagnosed with tuberculosis, 30 people were diagnosed with TB and HIV, 69 people were HIV positive, 51 people did not have either disease. So represent the information above in a Venn diagram, which is 7.2.1 for 4 marks. So, and then we'll read the other questions as we continue. So 7.2.2, they want you to represent the information provided to you in a Venn diagram. So you draw up your Venn diagram like this, right? You open up your rectangular box. Here's your rectangular box. And then you can call this sample space S. So when you draw a Venn diagram, you have to know number of your events first. So how many events do we have in this scenario? We have 2 events. which is TB, event TB, and event HIV. So that means we need 2 circles in our Venn diagram that represents these 2 events. Right, that's the first question. And then you answered the first question that you have 2 events. The second question is, are these events overlapping, or are these events written separately from one another? Because when you draw them in your Venn diagram, you're supposed to know that, am I going to overlap them, or am I going to draw them separately? So what's going to help you to decide on that? It is the very information provided to us. So when you have a look at bulletin number 2, it says to us, 30 people were diagnosed with both TB and HIV. This and TB and HIV, it shows that in this survey, there were people who were affected by TB and HIV. So that means these people, they are found between the 2 events of TB and HIV. So when you draw your events, that means you're going to draw them with an intersection because of that end, okay? Because of that end. So how many people are in the both events? So that means here we have event TB, and then here we have event HIV. So how many people are in both TB and HIV, this intersection? How many? They said 30 people. So that means here we're going to have, let me change my pen. So that means here we're going to have 30, right? So here we're going to have 30 people who are both tuberculosis and HIV. Now, let us fill the remaining information. So X people were diagnosed with TB. So X people were diagnosed with TB. Look, when they say X people, they refer to this circle over here. So they do not care, meaning people who have TB, we do not care whether they have TB only or they have TB and HIV. As long as they have TB, they fall within this circle. They fall within this circle. I don't care whether this person has TB only or he or she has a TB and HIV. As long as you have TB, you fall in this circle. But when we are talking about people having TB only, we don't want people with TB and HIV. We want people with TB only. They're gonna fall in this circle. Okay, this one that's like a C-shaped circle. We exclude this intersection, meaning TB only is here. Can you see that? This is where TB only is at. So how are we going to write TB only? We're gonna say X, the bigger X, subtract the intersection. So here we're gonna have X minus 30. So X minus 30, it represents TB only. Now, HIV only. Okay, now let's go to HIV. Let's read the information. They said 69 people were HIV positive. You see, 69 people were HIV positive. So, meaning, again, we do not care. As long as you are HIV, whether you have HIV and TB, you have HIV and what, you have HIV and flu, you have HIV and malaria, we don't care. As long as you have HIV, you're gonna fall in this cycle of HIV. So how many people are suffering from HIV? There are 69. But how many people are suffering from HIV only? Okay, so now we are interested to people who are HIV only HIV. Not HIV and TB, HIV only. We're going to draw them again in this circle. You see this circle? You see this circle? You see? You see this circle? That's why we're going to draw HIV only. So the HIV only, we're going to say, they say they're 69. So we're going to say 69 minus the intersection, which is 30. So that means we're going to get 39. 69 minus 30 is 39. Ah, okay. Therefore, and then 51 people did not have either disease. So that means 51 people do not have TB and HIV or HIV. Remember, survey was conducted among 180 residents. So the remaining number will come here. 51. These 51 people, they are not infected at all. They do not have TB or HIV, so they are out of our events. So that means they are in our sample space. Okay, I hope that was clear. So that means this is how we answer question number 7.2 for 4 marks. Okay, so our Venn diagram is complete. So this is how we draw our Venn diagram. This was 1. So now we move to 7.2.2. How many people contracted TB only? So people who contracted TB only, like I said, they are only in this circle. TB only, they are in this circle. This is TB only, not TB and HIV, TB only. We want people who have TB only. We don't care whether you have TB and HIV, we don't want you. We want TB specifically only. So how are we going to do that? So that means we need, this is what we need. TB only, we need TB only. We said it is equals to X minus 30. This is TB only, but they want a numerical value. They don't want our numerical, people who have TB only in terms of X. So that means we need to calculate X, and then we're gonna plug that value of X over here, subtract 30, we're gonna get the number of people who are infected by TB only. So let us determine X first. Okay, this is TB only. So now we're going to say in the Venn diagram, the events plus everything in the probability of the events plus probability of everything in the sample space is equals to 1. They are complementary. So that means, or you can say number of events, everything in the events plus everything in the sample space will be equals to total. So what is the total? People are 180. So that means everything, when we add it, we're going to equate it to 180 people. So that means X minus 3, sorry, minus 30 plus this 30 over here plus 39 plus 51. They're supposed to give us a total of 180 resident, as much as they told us. They took 180 people and they did a survey, and this is what they found. This is the stats or the results they found out of 180 people. So when we add these stats, we equate it to 180 people. So 30 will minus 30. Let's just do algebra. And therefore, you're going to say 39 plus 51. 39 plus 51, we get 90, right? So that means here, we're going to have X plus 90 is equals to 180. So let us solve for X. We're going to transpose 90 on the other side of the equation. Is going to be negative 90. So we're going to say 180 degrees minus 90. Why do I do this on my calculator? But it's fine. 180 degrees minus 90 is equals to 90. So the value of X is equals to 90. So this is, remember, the question wanted us to determine TB only, but we said that TB only is X minus 90. And then we go to substitute. People who are infected by TB only, we're going to say it's X. Our X is 90 minus our 30 over there. So that means 90 minus 30 is equals to how much? Is equals to 90, oh my God, 60. 60, right? It's 60. So that means we get 60. So people who are infected by TB only, there are 60 of them. Okay, that's how we solve 7.2.2. Now 7.2.3, it says to us, calculate the, now we are talking about the probability. Calculate the probability that a person selected at random will only, guys, when you read, be careful. Calculate the probability that a person selected at random will only have been diagnosed with TB. So that means we go back to our Venn diagram. We want probability, right? We want probability. We don't want number of people. We want, because we are selecting at random, we want chances of us out of 180 people. What is the chance of us getting someone with TB only? We're gonna select these people randomly. They are there, all of them. They are sitting there in a room, and we say they are 180. So what is the probability of me picking one person who has TB only? So probability is based on total number of our resident, which is 180. So for number A, 7.1A, I want to determine the probability of TB only. So now, what is TB only? Our favorable event, TB only, we said it's 60, right? So that means we're gonna say 60 divided by total number of resident, which is 180. So now we're gonna say 60 divided by 180, we get 1/3, right? We get 1/3, which corresponds to decimally 0.33 chances. These are the chances of us picking someone who is tuberculosis, infected by TB, by tuberculosis. Now, number B, it says to us, calculate the probability that a person selected at random will not have any of the two diseases, right? So we want to determine the probability of not diseases. Not diseases. So what is the probability of not diseases? We go back to our Venn diagram. People who do not either TB or HIV, don't know why am I making circle. You might think it's an event. So people, so people who do not have either TB or HIV, this is them, right? So they do not have either of the disease. So they want us to determine the probability. So it's going to be 51 over total number of residents, which is 180. So that means we're going to say 51 divided by 180. So it's 17 over 60. Decimally, which corresponds to 0.28 to 2 decimal places. Or you can just write, yeah, to 2 decimal places, 28. So that means this is the chance of us randomly selecting people who do not have either tuberculosis or HIV. I hope that was clear. Now, let us continue with question number 8. It says that in a certain class of 42 boys, class of 42 boys, they say 27 play hockey, 32 play soccer, 7 do not play hockey or soccer. An unknown number of X play both hockey and soccer. And the information is represented in the Venn diagram below. They just made everything to be just simple. They give you information and the Venn diagram. The previous question, they gave us information. They wanted us to draw the Venn diagram. You see now, you can draw your Venn diagram like this in terms of axis. So remember, when you draw your Venn diagram, determine the number of events. It's hockey and soccer. And therefore, do the circle overlap or do the circle do not overlap? So in this case, the circle overlap. Why? Because I said end, hockey and soccer. And this end, it means an intersection between the two events. And it is only X. We do not know how many of them who are playing soccer and hockey. We're just going to write X. But for hockey only, we're going to say what? Remember, learners who are boys who are playing hockey, there are 27. But remember, this 27, it does not matter. It's whether hockey only or hockey with soccer or hockey with another sport, let's say maybe volleyball, hockey, it does not matter. As long as hockey, there are 27 in class. But if we want learners who are playing hockey only based on these events, we're going to say 27 minus X and so forth. I'm not going to explain that again. I explained it on the previous video, but I can, if you want to ask a question. So now 8.1, it says to us, calculate the value of X for 2 marks. Remember, it's simple. The total sample space, it has 42 boys. So we're just going to add these numerical values and equate to the total number, which is 42. So that means we're going to say, to answer question number 8.1, we have to say 27 minus X plus X plus 32 minus X plus 7 is equals to 42 boys. So this X will cancel this X. So that means you're going to left with negative X. Now let's deal with the numbers. We have 27, 32, and 7. Let me add them on my calculator. 27 plus 32 plus 7. What do I get? I get positive 66, which is equals to 42. Now I have negative X. I transpose negative positive 66 becomes negative 66. So I'm going to say 42 minus 66. I get negative 24. I divide both sides by negative, and then my X will be 24. So calculate the value of X is 24. So that means 24 boys in that class, they play both hockey and soccer. 24, which is X over there. 8.1.2, it says to us, if a boy from the class is chosen at random, this is probability for sure, calculate the probability that he, the boy, does not play hockey or soccer. Okay, so we want probability of hockey does not play hockey or soccer. So how do we deal with this one? You can use your formula. I love using formula to simplify life. Do you remember that formula that says probability of A or B is equals to probability of A plus probability of B subtract probability of A and B, right? So that's what we are going to do. So remember, we want to determine does not play hockey or soccer, okay? So, or does not, sorry, not the hockey or soccer, does not. So here we have people who are playing hockey or people who are playing soccer, right? We have people who are playing hockey, we have people who are playing soccer. So we want those who do not play hockey or soccer, mean that in a sample space is this one. So 7, it is the only number that is standing alone there without soccer or hockey. Okay, so we're gonna say probability of does not play hockey or soccer. Does not play H or S. It's gonna be equals to how much? It's gonna be equals to 7 over total number of the boys in the class, which is 42. So we're gonna say 7 divided by 42. Our probability will be 1 over 6, which corresponds to 0.17. Okay, but this is the probability. All right. Now, number B, it says to us, calculate, where is it? Play, probability of plays only soccer, right? We want probability of plays only soccer. Remember, this is only soccer. This over here is only soccer, right? It's only soccer. So this number over here, it presents number of boys who are playing only soccer. So only S only It's going to be equals to how much? It's going to be 32 minus x. We have already determined the numerical value of x to be 24. So what is 32 minus 24? We get 8, right? We get 8. So let us determine probability of S only. Now we're going to say probability of S only is 8 over total number of the boys in class. So which is 8 divided by 42. It's how much? We get 4 over 21, but decimally we get 0, 0.19. This is the probability of soccer only. Okay? All right. So now, and then we move to 8.2. 8.2, it says to us, a bag contains 3 blue balls. We have a bag. This bag, it has three what? Blue balls. 1, 2, 3. And X yellow balls. And X yellow balls. So we have X yellow balls. We don't know how many X balls do we have in a bag. All right. So now, write down the total number of balls in the bag for number 1, right? So now, how are you going to write total number of this thing, 8.2.1? So total number of balls, let me just say total. Write down the total number of balls in the bag. How many balls are in this bag? It's 1, 2, 3, X. We don't know X, right? So we're gonna write it as it is. It's X balls. There are 20, 16, 4, 5. You don't know. We're just gonna write X because it's not even provided. There is not even enough information to say how to calculate that. So that means it's gonna be 3 plus X. This is the total number of the balls in the bag. Okay. All right. So now we move to question number 8.2.2. 8.2.2, it says to us, if a ball is drawn from the bag, is drawn, okay, it's drawn, you're going to pull it without looking. That's the probability. Write down the probability that it is blue. Write down the probability that the bag, not the bag, the ball, when you choose it randomly, it is blue. So you're going to say probability of blue is equals to how much? How many blue balls are we going to pick from in the bag? There are 3. Therefore, how many number of the balls, total number of the balls in the bag? We said it's 3 plus X. This is a probability of us choosing a blue ball in a bag. Okay? All right. And therefore, now we move to the second question, which is 8.2.3. Oh, 0.3.1, right? They say to us, 8.3.1, complete the following statement, right? So now, if A and B are 2 mutually exclusive events, then what is probability of A and B? When events are mutually exclusive, they do not have intersection, okay? They are exclusive. But when they are mutually sharing the intersection, therefore they are inclusive. We have intersection over there. So what is the probability of A and B here? It's 0. It doesn't exist. So it's going to be 0. Okay. 8.3.2, it says to us, given that A and B are mutually exclusive events again, right? The probability that event A occurs is 0.5. Probability that event A occurs, it is 0.55. The probability that the event B does not occur is equals to how much? B does not occur is equals to how much? Is equals to 0.70, obvious. Calculate the probability of A or B. So here we have probability of A. And then here we have probability of not A. So probability of B, because we want to determine probability of A or B. And then remember,